Hi everyone, so today we should all take a look on, page 30, and we are going to be talking about complex numbers and imaginary solutions today. So I will be walking you through this lesson as usual. Alright, so today's objective, as already stated. Okay, this is actually really fun. I really love this lesson. So let's take a look at the first exercise. So the first exercise, we have a polynomial has the following factors. Determine if they are roots of the polynomial, expand the factors to find what the polynomial is, and then verify the number of positive and negative roots using Descartes' rule of signs. So first part should be pretty easy. Find the roots. Well, to find the roots, we're just going to t-chart this. T-chart, we'll get x equal negative 9, x equal negative 2i, and x equal positive 2i. So we'll have x equals negative 9, and then plus or minus 2i. Remember, imaginary roots come in conjugate pairs always. Okay? And expand the factors to find the polynomial. Well, we're just going to multiply x plus 9 times x plus 2i times x minus 2i. So I like to deal with the imaginary part first, okay, because this is actually going to simplify pretty nicely for us. So let's do our double distribution, leave the x plus 9 alone. We'll have x squared minus 2xi plus 2xi, and what is that, minus 4i squared. Remembering I squared is negative 1. So this is negative 4 times negative 1. So this is really plus 4 here. So I'm just going to write that. And notice the negative 2xi plus 2xi, these terms cancel. So we're left with x plus 9 times x squared plus 4. And now we want to double distribute this. Okay, I got all of this from doing the double distribution here. I just saved us some time from doing the algebra. So now let's double distribute. Let me erase this for some space. We have that x plus 9 times x squared plus 4. And double distribute. We have x cubed plus 4x plus 9x squared plus 36. And I want to write this in standard form. So I'm going to write x cubed plus 9x squared plus 4x plus 36. And that's my final answer here for expanding the polynomial. And then lastly, verify the number of positive and negative roots using Descartes' rule of signs. So here we're going to use, we have x cubed plus 9x squared plus 4x plus 36. So there are no sign changes here, right? None. So that means we have 0 positive roots. Okay, oops, I didn't mean to erase that, sorry. And now if we input the negative x, so we have negative x cubed plus 9 times negative x squared plus 4 times negative x plus 36. We'll have negative x cubed plus 9x squared minus 4x plus 36. Remembering negative x squared is always going to be a positive whenever you square a negative number or even raise it to the 4th, raise it to the 6th. Any kind of even exponent, the outcome will always be positive. Okay, the outcome will always be positive. It's when we raise a negative value to an odd degree that result will be negative. Okay, so let's see how many sign changes do we see here. I see 1, 2, 3. So that means we have 3 or 1 possible negative roots. Alrighty. And exercise 2 is very similar. You can try this on your own. So I'll pause the video here if you want, but you can try exercise 2 on your own and I'll post the solutions. But it's very similar to exercise 1. So if you want to pause the video here, I'm going to post the solutions now. All right, so those are the answers for exercise 2. All right, so I'm about to show you how to get this expanded in the calculator to this in just a few clicks of the button. So follow along with my screen here on the calculator. So if you just go into your home screen and we're going to hit F2, scroll down to expand, F2, scroll down to expand, and now I'm just going to multiply all of the factors here, all of these factors. So we have, I just got to raise this up so I can see what I'm doing, parentheses, x plus 1 times x minus 1 times x minus 1 minus 2i. To get I, we hit second catalog, close those parentheses, times x minus 1 plus 2 second catalog, close parentheses. And I'm going to hit the comma button. So comma is right here. Comma x, close parentheses. So I typed in all of my factors being multiplied, comma x. I hit expand, click enter. And now if you look, okay, so I'm just going to try to hold this as steady as I can. Now you look, here it is. That is the polynomial expanded. All right, so I just showed you that calculator trick. Now let's move on to the next page. So we should be on page 31. Now I love questions like exercises 3 and 4. You can definitely expect to see something like that on a test because now it's making you look at the graph. So we have shown below, we're given the following function. And I want to know, is there a relationship between the real zeros and the number of x-intercepts? How many roots should there be? How many roots should there be? Find the other roots. So we're given the polynomial. Now, I have f of x equaling x cubed minus 4x squared plus x minus 4. The degree here is 3, so I should have 3 roots total. I should have 3 roots total. But if I look at my graph here, I have 1 root. So this is what we should have, but in actuality, we have 1 real root. So if I have 1 real root, and I'm supposed to have 3, what does that mean the other 2 are? That means the other 2 roots have to be imaginary. The other 2 roots must be imaginary. Okay, so we should have 3 roots. So let me rewrite this. I don't like how I wrote that language. Should have 3 roots. We have 1 real root. The other 2 must be imaginary. Okay, so I just underlined the key pieces there. Okay, let's talk about the signs of the roots, whether they're positive or negative. So we have f of x. So we're going to use Descartes' rule of signs here to determine whether the roots are positive or negative. And let's see. So here we have 1 sign change to 3 sign changes. So that means we have 3 or 1 positive roots, which we did expect because look, I have 1 positive root here. So in actuality, we have 1 positive root, okay, in reality, because I have the graph. We should have no negative roots. If you look over here, there are no negative roots, right? The other 2 should be imaginary, so let's just check with Descartes' rule of signs. We have f of negative x will equal negative x cubed minus 4 times negative x squared plus negative x minus 4. And I'm just going to simplify here. Negative x cubed minus 4x squared minus x minus 4. I have no sign changes, none. So that should make sense that we have 0 negative roots. That should make sense. Okay, so Descartes' rule of signs upholds, which it always does, so you want to make sure you're doing the work right. Okay, so we have number of x-intercepts. There's 1. How many real zeros? Just the 1. How many roots should there be? We said there should be 3 total. Find the other roots. We want to make sure we're answering everything. So find the other roots. Well, hey, here's my function. X equals 4 is a root. That's a linear function. So you have options. You can either do synthetic division or long division. I prefer long division, but synthetic division is just quicker, so I'm going to use it here. So I have 4, 1, negative 4, 1, negative 4. I am using this function here. There are no zeros. No terms are missing here. So I'm using this function because we know x equaling 4 is a root. So when I do synthetic division on this, I will have no remainder. Okay, I'm just applying synthetic division. And there we go. Okay, I shouldn't have to go through all that. You guys know your synthetic division. So I'm left with x squared plus 1. Now, that's the remaining piece, right? When I do long division on this, so if I'm going to write this over here, if I did x minus 4 going into this whole thing, that's what I'm left with. And it went in evenly. So we can set this equal to 0 and find the remaining roots. So let's do that. I'm running out of space, so I'm writing down here. I have x squared plus 1 equals 0. Well, if I solve for x, right, square root both sides, I get x equaling plus or minus I, because the square root of negative 1 is I. Don't forget that when you square root both sides, you need plus and minus. Imaginary roots come in conjugate pairs, so if you just wrote x equaling I, you should know you're wrong. You always need a plus or a minus in front of imaginary roots. So those are the remaining roots. Find the other roots. The other roots are x equals plus or minus I. Okay, let's move on to exercise 4. Again, another question that I really like. I'm going to erase the work here so we can write. So for exercise 4, again, we're given the function, so it's raised to the 4th power. How many solutions should there be? So how many solutions should there be? Why does the graph contradict any real possible solutions? And find all the possible solutions. Okay, so we're finding all the possibilities. Well, let's see. If we look, okay, this thing never actually crosses the x-axis. So this actually, I mean, that is when y is equal, but I'll just write this is the x-axis. This is our y-axis. So we never actually cross the x-axis. So we should have 4 roots, but in actuality, we have 0 real roots, which means 4 roots are imaginary. Okay, we got to think. You should have 4 roots. We have no real roots, so there are 4 imaginary roots. Okay, so the graph doesn't cross the x-axis, indicating the roots are imaginary. So that's why, does the graph contradict any possible solutions? Yes. Okay, so that's my answer for this purple piece here that I highlighted. The graph does not cross the x-axis, so the roots are all imaginary. Okay, let's just check with Descartes' rule of signs to just verify that there really should be no real roots. So I'm going to use Descartes' rule of signs here. So I'm just going to write that down here, again, because I'm running out of space. So I have x to the 4th plus 4x squared plus 4. So, yep, I can easily see there are no sign changes, none. No sign changes. So that tells us there are 0 possible positive roots. Okay, real roots. So there are 0 possible positive real roots. Let's check when we plug in negative x. So let's see what happens. And because negative x is being raised to an even exponent, these still stay negative. So again, there are no sign changes here. So no or 0 possible negative real roots. Okay, so I just used Descartes' rule of signs to just confirm this. Alrighty. So again, we answered all of our questions here. And then it says find all possible solutions. Well, that's just it. All 4 solutions are imaginary. I can't actually solve this. So all 4 roots are imaginary. Can't actually solve this because I was giving nothing that was a root. All right, I'd like you to try exercise 5. So I'll erase all the work here, but I want you to give exercise 5 a try on your own, and then I will reveal what the answer is. So try exercise 5 on your own. Now, these are what your factors should look like before you have solved this, expanded this out, sorry. These are what the factors are. I don't tell you this, but remember, if I give you 7i, you got to remember it's plus and minus. Imaginary roots come in conjugate pairs. And I'm just going to multiply these two, and I'm going to multiply these two before I multiply them all together. All right, so I'm just going to pause the video here. You guys know how to do algebra. So I'll just write out my work, and hopefully it all makes sense. All right, and that is my final answer boxed down here. X to the fourth plus 49x squared minus 98. So just make sure your algebra is all correct. Pretty straightforward question. All right, so we're going to flip over to the next page. I want to take a look at exercise 7. Exercise 7. Okay, so I give you the following polynomial, and I tell you this is a root. Find the remaining roots. If this is a root, it's imaginary. So you need to remember, if x equals 5 plus 2i, what's the other root? 5 minus 2i. They come in conjugate pairs. So you have 5 plus or minus 2i are the two roots. Now, this gets a little tricky, okay? We want to figure out what the remaining roots are, right? This possibly has 3 total roots. So this has 3 possible total roots. Well, sorry, it's not possible. It has 3 total roots. It's a matter of whether they're real, imaginary, whatever. So we have 3 total roots where we know already off the bat 2 of them are imaginary. Find the other root. So we have 2 imaginary. The other one obviously has to be real. So let's find it. So the way that we start these off is I'm actually going to multiply the factors of these 2 roots. So if I were to undo x equaling 5 plus 2i, subtract 5, subtract 2i, because I want the factors, right? I'm just undoing this. So that's a factor now. Same thing here. X equaling 5 minus 2i, subtract the 5, add the 2i, add the 2i. Now I have x minus 5 plus 2i equaling 0. Here's another factor. If I multiply those factors and perform long division on this, I will find the remaining factor. All right, so I'm going to multiply those things. So I'm just erasing this to make some room. Okay, so we're going to multiply x minus 5 minus 2i times x minus 5 plus 2i. So now I'm just going to multiply. I have x squared minus 5x plus 2xi. It's going to get long here. Okay, there's going to be a lot to write. Negative 5x. We have positive 25 minus 10i. And let's go with green. Minus 2ix, or you should really be writing minus 2xi, plus 10i, and we have minus 4i squared. Remember, I squared is negative 1, so this whole thing here is really plus 4, so I'm going to write that, plus 4. And you're going to see a lot of things cancel. We have negative 5x ends up combining with the negative 5x. The imaginary term should go away. That's the whole point of this. This positive 2xi cancels with this negative 2xi. Gone. We have negative 10i plus 10i. Gone. And these are the things that are left remaining that I'm boxing. So let's see, is there anything we can combine? I have x squared minus 5x plus 25 plus 4. We can combine like terms. And now that we've multiplied our factors, we can perform long division on this to find the remaining factor. So let's do this. Let me write this over here because I'm running out of space. I have x squared minus 10x plus 29 is going to go into, you'll see why. Do you understand why now I prefer long division? It works for all of these kinds of problems. Synthetic will not. And now we're just going to apply long division. Like I said, I'm running out of space, so just follow along. x squared times x gets me x cubed. Multiply it back. So I have x times x squared is x cubed. X times negative 10 is negative 10x is negative 10x squared. And x times 29 is positive 29x. Distribute the negative. Plus, minus, gone. We have 3x squared. Okay, so these terms here combine. 3x squared. Negative x minus 29x is negative 30x. Bring down the 87. And again, long division. X squared times 3 gets me to that 3x squared. Remember, we multiply it all back. So let me erase this so there's nothing confusing going on here. Oops, didn't mean to erase the x. Okay, multiply it back. 3 times x squared is 3x squared. 3 times negative 10x is negative 30x. And 3 times positive 29 is positive 87. Distribute the negative. Distribute the negative. Gone, gone, gone. My remainder is 0, which we wanted, and we knew that was going to happen because this is factored into this evenly. We were told that this factorization makes up roots for this polynomial. Okay, so that's the last factor, guys. If x plus 3 is a factor of this polynomial, set it equal to 0, and there's my last real root. X is negative 3. That was everything I wanted to get to with you. I do just want to show you one more example. So let's go to page 34, exercise directions exercise 4 here. Okay, so for the directions, it says, using the given 0, find all of the zeros, and then write it as a linear factorization for f of x. So we're going to do the same thing again here. I'm telling you, 1 plus I is a root. This is a root for this polynomial. Imaginary solutions come in conjugate pairs. So I have x equaling 1 plus I and x equaling 1 minus I. We know that these are roots for this polynomial. So if I want to figure out what the remaining factors are, we're going to get these into factored form. So we'll have x, so let's write this out, x equaling this, minus 1 minus I, right? We set it equal to 0. We undo it being a root, so now this is a factor. Over here, I have x equaling 1 minus I, so subtract 1, add I, subtract 1, add I. And now I have x minus 1 plus I equaling 0. Again, that's a factor. Because these are both factors, of this polynomial, we can multiply them. So I have x minus 1 minus I times x minus 1 plus I. Again, it's just going to be, just a bit of long work here. I'm going to try to do this quick. X squared negative x plus xi. All right, I have negative x plus 1 minus I, and I have negative xi plus I minus I squared. Remembering, I squared is negative 1. So if I have negative I squared, so let me write that out. That was minus I, plus I, minus I squared. I squared is negative 1. So if I have negative I squared, that's positive 1. So this here is really just going to be plus 1. And you'll see a bunch of things cancel. Let's see. Positive xi, negative xi are gone. Minus I plus I are gone. And I'm left with x squared minus x plus 1 plus 1. Simplify this and we get x squared minus 2x plus 2. And now I know this is divisible by this because we just got it from being a root to a factor, so from a root to a factor, multiplied the factors and got a simplified polynomial. We know this here is divisible by this polynomial. So I'm going to run long division. All right, and this is our last problem. So again, we're doing long division here. I have x squared times x squared gets me x to the fourth, and we're going to multiply it back. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times positive 2 is positive 2x squared. We're going to distribute the negative, plus, minus, gone, gone. Oh, that's nice. And I have negative 3x squared. Bring down my remaining two terms. And let's see. Now we have what? X squared times what gets me to negative 3x squared? Well, it's a negative 3. Multiply it back. Subtract it out. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2x is positive 6x. And negative 3 times 2 is negative 6. Distribute that negative. Distribute that negative. And would you look at that? There's no remainder. There should not be a remainder because we knew this factored into this polynomial. So guys, that's my remaining factor. X squared minus 3 has to equal 0 because this goes into it evenly. We're looking for the roots. So now I'm just going to solve for x. Now I'm just going to solve for x. Square root both sides. Remember, when you square root both sides, you need that plus and minus. So x is equal to plus minus radical 3. So if I want to write out my 4 roots, we have x equals plus minus rad 3 and x equals 1 plus or minus I. Those are your 4 roots to this to the zeros of this polynomial. Alrighty, everyone. Talk soon.